Hello everybody, this is Mrs. Braband again. We are now going to move through our Unit 3 to Target 3. Again, exponents, but now you'll notice we're doing reducing and division. So with addition, remember, when we when we multiplied our variables and they had powers, then we just added the powers. But now that they're divided, one of the quick rules is we can subtract them. In other words, if you take a quick look here, if I have a to the x power and then the same base but to the y power, then what we would do is we'd keep the base the same and then we would subtract the powers and then we would be done. The only way that I would change that is if when I subtracted that became negative, then I would have to use that reciprocal property. So let's just start with the first one and let's separate as we always do with each piece and then kind of talk through each move. Again, y's with y's, x's with x's, z's with z's. Now in this case you only have a z that's in the numerator. There's nothing in the denominator, so I'm just going to put the number 1. There's also not a power on the z, but it's really there to be counted, so I'm just going to put the 1 to remind me. So we treat fractions like we always do from way back when in grade school and junior high. So that's just going to be a 5 coming out of both of those. No new rule on that. That's going to be a 1 and then 15. Now with the x's, we're going to, in order from top to bottom, we're going to subtract the powers. We're going to do the same thing with the y's. That's going to be a 10 minus 7. And then the z's, there's no subtraction needed. It's just going to be left by itself. So right now we've got negative 1/15. Looks like we've got an x to the negative 1. That's not, we don't want to leave negative, so we're going to end up changing that in a moment. This is going to be a y to the 3rd. That's positive. It's going to stay right in the numerator, and z already is there. So I'm going to scooch down to the bottom. I'll do this in another problem. Start to make my long fraction here. The negative is going to come from the negative 1. I'm not going to write the 1 because it's not going to really help change the problem. 15's in the bottom. Now that x to the negative 1 tells me it's a reciprocal, so it's going to come to the bottom. The y to the 3rd being positive as is stays, and the z being positive stays. So this is really our final answer right there. Okay, and one of the ways you want to always kind of check your work to see if you're okay is when you look at the original setup, wherever the biggest power is, that's where your leftovers, if you will, are going to remain. So in the x's, the 4 was bigger in the bottom, so your answer stayed in the bottom. But in the y's, your 10 was bigger in the top, so your answer stayed in the top. Let's go to the next one. All right, let's separate this. I'm going to immediately just reduce my negatives and just go here. And then x to the 3 minus 2. It's kind of hard to read. 3 minus, negative 2 as a power. And it's going to be negative 7 minus 4 and nothing else. Okay, so coming down here again, I just changed those because negative divided by negative is positive. In here, it looks like we've got a 4 into both of those, so that's going to be a 3 and that's going to be a 7. This is going to turn out to be x to the 3 plus 2. Subtracting the minus, sign is turning to positive. And this is going to be a y to the negative 11. So we're going to be careful, and again, positive powers are going to remain in the numerator, and then the negative powers that are already sitting up there by themselves will use a reciprocal and change to the denominator. So I'm going to start my big fraction here with my 3/7. X to the 5th is positive, it's going to stay in the numerator, but y to the negative 11 indicates it needs to go into the denominator. So there it is. Scroll down and do this one here. I'm just going to recalculate if you don't mind. Now this is a little different because we don't really have a fraction for subtraction. We do have powers that are inside the parentheses and then this power outside. A couple ways to handle this. You could do one large reciprocal using that power right off the bat. Or you could do a distributive property and then use the rule of multiplication. There's just a lot of ways to do it. You kind of need to hold on to what you're feeling great about. My gut tells me to first do multiplication, that would be a positive 4 there. And then second, that would be a negative 10. So we're literally just distributing this outside power. Now, that means we have to finish because that negative is going to indicate it goes to the bottom. Oh, that should be a 10, sorry. That negative is going to indicate it goes to the denominator as a reciprocal, and then that's going to be there. So that seemed pretty straightforward. Didn't have too many extra steps. I kind of like that. Let's try this one. Well, we got to rearrange here. So I'm going to put, and I may need some more room here. I'm going to put 2 with the 9, and I'm going to put the 6 with the 10. And then I've got 2 sets of x's going on. And down here, 2 more sets of x's going on. And then my y's, I've got in the numerator and my y's in the denominator. So I've got a little bit of work to do here. Some positive, some negative. Some where I'm going to add the powers. Some I'm going to flip them over. Some I'm going to end up subtracting. So let's just kind of keep this going here and just think through this. All right, so I'm going to go right here and recognize 2 divides out that and leaves a 5. 3 goes out of both of these and leaves a 2 here and a 3 here. So that's going to be a 2 on the top and then 3 here. And so if I work that out, I get 2 over 15. Now I could do that 12 over 90 and then reduce everything by 6 as well. That's another way to do it. We're going to the x's. I'm going to be a little bit careful here. Right now I'm going to add the powers. That's going to be x to the negative 1. Ooh, that's an x to the 0. That's going to end up going away. The y's, y to the 5th here, now y to the 4th here. So what I want to really be careful at is what other powers tell me what to do here. So this here, don't forget anything to the 0 power turns into 1. In other words, we lose the variable. And it just turns into 1. So I've got an x to the negative 1 over 1. So that's really telling me I move this down to the bottom, and then this is just, because it left, it's the 1 left over. This is going to be a y to the 5 minus 4. So what we're getting is a big fraction here is a 2 in the numerator, and go straight across, times 1 times y to the 1. Excuse me. And now on the bottom, 15 times x, and there really is no other variable there. So it looks like we're finished. And that is the 4 of them, or excuse me, 3 of them for target 4. Now I've got this guy finished. I believe, did I do all 4? I did all 4. Yes, so what you want to be careful about is where they are. If they're a fraction, you want to subtract, but if they're on the same position like numerator, you want to add, and then if it's a negative power, you want to flip it over. So here's a rule with subtraction for division. Here's a rule with 0, and then the other rule, which I'll slide right in here, is if you happen to get a negative power, okay, that means you flip it over and make it positive, okay? All right, I will post this for you.